So I was talking about building integrated photovoltaic panels. So these are parts of the building that effectively replace the traditional external wall or external roof or windows that we use in our buildings with a photovoltaic module. And I'm talking about the risks of fires either developing in those modules and spreading via the facade or via the roof, or a fire that originates near these panels, affects the panels and then spreads through the building. So the research really is practical. It's been applied on a few buildings, looking at firstly what are the fire risks associated with PV panels, looking at how building integrated photovoltaics might differ from building applied photovoltaics, and how to mitigate the risks of ignition and fire spread from these various sources. And the presentation included a few case studies where we've actually obtained approval and actually partway through or completed construction on several buildings with these types of technologies. I think a well-informed fire brigade, as part of the design authority having jurisdiction looking at the design, can ask these sorts of questions and protect themselves and the community. These are things the fire engineer might not think about themselves when they're designing the system. I'm aware that some building integrated photovoltaic systems are being installed and just compared to laminated glass, just a typical curtain wall, with almost no scrutiny by the fire engineer, with really no understanding from the electrical or facade engineer how this is actually going to affect the building response to the fire and the fire brigade's response to that fire. So it all needs to be considered in a really holistic way. So that's really the message. It is a holistic design. It's not just a piecemeal, one person in a corner thinking about how they might address these challenges. It's really a team sport.